Okay, today we are working on the third set of notes for factoring and simplifying polynomials. The goal is that we're going to be just working on the first page of notes. Today we're going to be talking about two different types of factoring. One is called factoring by grouping and the other is called difference of squares. Obviously when we were in the quadratics chapter, there was 4 different ways that we could solve. We could complete the square, factor, quadratic formula, or square root. But every method had a certain time and place when it could be used. So the same is going to be true for these methods. These are just some of the methods. It will not work all of the time. So for our first example, just like when I introduced factoring to you, we could either use the foiling method or we could use the box method. So for those of you who do the box method, you can still do this with the box. You would draw your 2 by 2 box. And now since I have 4 terms, all the terms get filled into each box. So I have an x cubed, a 4x squared, an x, and a 4. So the other option, again, is you're factoring by grouping. So I would group my first 2 and I group my second 2. For those of you who do the box, go ahead and find the outside. I'm going to do this during the foiling method. So my first binomial, the largest quantity I can take out is an x squared. And if I take an x squared out, I'm left with an x plus 4. My second binomial, I could take out a 1, and I'd be left with an x plus 4. From here, my two final binomials become x squared plus 1 and an x plus 4. And this will be our final answer. So we have now factored to the third power. For those of you who do the box method, you can go ahead and check your work. So for that first column, I could take out an x squared. For the first row, I could take out an x. For the bottom row, I could take out a 1, and for that right-hand column, I could take out a 4. So your answer is still x squared plus 1 and an x plus 4. So notice, regardless of which method you do, you'll still get the same answer. For this factoring by grouping, notice that I did not need to multiply a times c to find that middle term of b. So this is a different type of factoring. In order for factoring by grouping, in order for it to work, these two binomials must match up. If they don't match up, it can't factor by grouping. Similarly, for those of you who do the box, when you go to find your outside 4 terms, if you can't find a combination that works, that means, well, then factoring by grouping isn't the best method for this cubic function. So letter C is what you're going to see on the park. So obviously on the park, they're not going to just give you a basic one with all x's. They're going to throw several variables at you. So here is an example of what you would see on the park. Again, for my boxers, you draw your box, fill in each box. So we have a 2xy, a negative 3xm squared, a negative 4my, and a 6m cubed. Go ahead and find the outside of the box. For my non-boxers, my FOILers, we're going to group them. So I group my first 2 and I group my second 2. The largest quantity I can take out of my first binomial is an x. If I do that, I'm left with 2y minus 3m squared. Largest quantity I can take out of my second binomial would be a negative 2m, and I'd be left with 2y minus 3m squared. Again, notice my two binomials match up, so that's how I know I can definitely factor by grouping. And my final answer would be x minus 2m and a 2y minus 3m squared. Again, for those of you who did the box method, go ahead and check to see if you got that as your same final answer. So for tomorrow in that section, I would like you to try letter B and letter D. Last thing I want to go over with you is something called the difference of squares. And the difference of squares, again, can only be used with quadratic functions. So a quadratic function means that it has to be squared. So the formula for a difference of squares says that a squared plus, not plus, sorry, difference, a squared minus b squared will factor down to be a plus b, a minus b, always. So the goal here is that this is the shortcut. I want you to start using the shortcut if you have two values that are both perfect squares and they are being subtracted. So for your last set of examples, as long as you can identify your a and b value, meaning the perfect squared values, all you have to do is fill it in the formula. So for letter A, my a value would be x, and my b value would be 10. X times x is the x squared. That's how I got that value. 10 times 10 is 100. That's where I got that value from. Once I've identified a and b, I can just say that this will factor down to be x plus 10 and x minus 10. Okay, so that's letter A. Letter B. Okay, so again, we figure out what was this quantity before it was squared, so what times what would give me 25x squared, so that would be a 5x. My b value is, we have a 16, so that means my b value is 4. 4 times 4 is 16. That's where the a and b are coming from. So my final answer is 5x plus 4 and a 5x minus 4. Done. That factored down. So last example. My a value would be x. X times x is x squared. And my b value is 6y. Is 6y times a 6y is a 36y squared. So my letter C will factor down to be x plus 6y and an x minus 6y. So whenever your a and b, or your first and last terms, are perfect squares, you can always apply this shortcut to factoring. So essentially notice that middle term is always canceling. So again, for tomorrow, I would like you to try letter B and letter D on factoring by grouping. If you have any additional questions, jot them down on your question box. Okay, that's all for today.